Right, that leads us to our final little section, validator activity statistics. So this is just the collection of statistics on chain for making sure that validators are doing their job and paying them accordingly. Right, it's under state item pi. Pi is a sequence of two things. We actually retain two sets of statistics. We retain our statistics accumulator, so basically the current epoch's accumulator of statistics, and then we also retain the last epoch's final statistics. Because, you know, it's not so useful to know what the statistics are halfway through an epoch. You want to know what they are after, at the end of the epoch, when they're finalized. So basically, chains or whatever services have an epoch to read the statistics and act upon them. Yep. Good. So what's in here? We've got 6 items. Number of blocks produced by the validator, the number of tickets introduced by the validator in Safrol, number of pre-images introduced by the validator, total number of octets, bytes amongst all those pre-images that they were introduced, the number of reports guaranteed by the validator, and the number of availability assurances made by the validator. Of all of these, this one is by far the most important, because this one is what you get slashed for if it's wrong. If they do all the others but they don't do point G, then they're not going to get paid very much. All right. So formally, we're going to go back to having an M, which is our it's T mod E, so it's basically our epochal phase, and M prime, which is our posterior epochal phase. So M prime is probably going to be one more than M, but if it's on the last block of an epoch, then it'll be 0, whereas M will be 599. All right. So if we're in the same, if it's equal. Okay, this shouldn't be mod, this should be divided by. All right, so it's actually, that should read tau over E, and it should be should be the floor, and then that should be tau prime over E. Okay, all we care about this is whether we're in a new epoch or not. If we're in the same epoch, then we're going to take pi 0, the first item in this 2-item sequence. That's going to become A, and pi 1 is just going to go to posterior pi 1. It's going to remain the same. Okay, so very simple. Pi 1 doesn't change. A, and pi 0 is pulled out into A. If we are in a new epoch, then we're going to initialize pi 0. We're going to initialize A with lots of zeros, everything just being zeros. And pi 1 is going to be pi 0, but with this A function applied to it. We're in a different section now, so it's not the accumulate function. It's another A function that we're going to define in a second. All right, and let's go in. Let's define it. No, we're not going to define it. Okay, let's for now assume that A doesn't exist. So we're just going to say pi 0. It probably more or less is pi 0 anyway, because pi 0 is the original accumulated, the last epoch's accumulated statistics, which is just going to put into pi 1. All right, so let's see how pi 0 gets altered from A. So if you remember, A is the previous pi 0 or zeros in the case that we're at a new epoch. We're going to take the blocks produced and add 1 if we are the author and 0 if we're not. This is for every validator. Yeah? So every validator has some statistics associated with them, these 6 statistics. And we're going through every validator And we're going to add 1 to their block count if they are the validator, if they are the author of this block. Very simple. Next one, T, SAF roll tickets. If they're the author of the block, we're going to also add the number of SAF roll tickets that they introduced into the block, into this SAF roll tickets counter associated with them. Okay. We're going to do the same for pre-images. If they're the author of the block, increase their pre-image counter by the number of pre-images they introduced. And if they're the author of the block, increase the pre-image data counter by the total amount of pre-image data that they introduced. So far, so obvious. So the final 2 things are a bit different. This is the amount of guarantee reports that they did, and the amount of assurances that they did, that made it on chain anyway. Amount of guaranteed reports is we're going to add on whether their key, that's kappa V, was in R. So if you remember way back, big capital R was the reporters set, and it was derived from the extrinsics. The guarantees extrinsic. It was all the reporter keys and the guarantees extrinsic. Well, now we're going to try and find this validator's key, and if this validator's key is in there, we're going to give them a point. If it's not in there, they don't get a point. So basically, if this guarantor's been reporting, they get the point. Similarly, we're going to add on, if there exists an assurance such that the validator index is us, we're going to give them a point, and not if there isn't. This is a little bit, I've been a bit in here, and here. I could have said something like, if it's V, 1 when V equals HA and 0 otherwise, but I'm being lazy and I'm just using the Boolean expression and sort of coercing it into a number. 0 if it's false, 1 if it's true. It is mentioned, but just to make it clear. And this is the end of the on-chain logic. What comes next is the off-chain logic